just focus, get your pencil up. Okay, so I'm starting to get a little pissed here. So, all right, so we're going to talk about solving linear systems by substitution, part 2. Yes, we are already running. Thank you. We talked about it yesterday, and the important thing with this is that you're always looking for, you're given 2 equations, right? In algebra 2, you might be given 3 equations, but in this case, we're only going to deal with 2 equations. Sometimes you might be given 4 equations or 5 equations. But for substitution, you have to have one of them say y equals or x equals. They don't both have to say that, but one of them does have to say that. They can both say y equals, and then you get to choose which one to circle, right? So let's just do one. Well, let's see, I did that one. Okay, all right. Let's say I did this. Yeah, let's do this one. X equals 2. Oh wait, that sounds like the one I did on the homework. Okay, hang on. We'll do this one. How about negative? Let's do y is equal to x plus 3, and we'll say negative 2x plus y is equal to 2x plus 5. Not 2x plus 5 is equal to 5. Sorry, I'm changing the thing around. All right, so I have 2 equations, and I notice one of them says y equals, right? Y equals. So what do I do?
Circle x plus 3.
Circle, right. Circle x plus 3. And then what do I do? I put a arrow.
To the y.
That says y is this, right? And I'm going to now bring that down to this y. And I'm going to substitute this in for this y. And the beauty of doing this, yes?
So would it so would you turn it into 3x, or would it just stay x plus 3? Yeah.
It's going to stay x plus 3. Good question. It's good, because 3x is not the same as x plus 3. 3x is 3 times 3. This is 3 plus x, or x plus 3. Totally different things, right? So you want to have it exactly what's here. So I'm going to write negative 2x plus, and now it says y, so it says x plus 3, and then equals 5. Now the beauty of this method is that now I have one equation that has only one type of variable. You agree with me? I've only got x's. So if I have one equation with one type of variable, then I can solve it. I can always solve an equation with one variable.
Instead of subtracting, would you add negative 2x plus x and would get x plus 3 equals 5?
Well, what would be,
1x.
this is a 1, right?
Oh yeah, sorry, negative 1x.
Yeah, so it would be negative 1x. Let's
Or
do
just
that.
negative x.
So we've got negative 1x or negative x. Personally, I would just do the negative x, right? But either way is fine. Excuse me. Plus 3, right? Equals 5. Now what would I do?
Minus 3.
Minus 3. Minus 3. So I have negative x is equal to 2. Is that right?
So then positive x would equal negative?
Yeah, so the opposite of this has got to be equal to the opposite of this. So if I multiply both sides by negative 1, I would have positive x is equal to negative 2. Okay? And so that's my first part of my solution. Am I done?
No. Because you
Why?
haven't figured out y
I
yet.
have to figure out why, right?
Okay.
So that's really important. So what?
It's super easy though.
Right, super easy. And it's super easy because it already says y equals in one of the equations. I could substitute the negative 2 into this one, but it would take a little longer to solve it. But this is so easy because this says now y is equal to, right, x, which is negative 2, plus 3, so that is 1, right? So I just say y is equal to 1, and I put a box around it. Or I could write it as this, negative 2, comma 1 in parentheses, so that it's a coordinate, right?
Wait,
Yes.
sorry, I was doing some notes. How do you solve y again?
Once I found out what x is, I go back to one of the two original problems, right, that were given, and I choose. Doesn't matter which one I choose, but I like to choose the easier one, right, to solve with. And I'm going to substitute the -2 in for x. So I like this one. I'm trying to find y. This says y equals. That's perfect. It's already set up for me. So I'm going to take that -2 of the x. I come up to the x here, and I put -2. So y is equal to -2 plus 3. -2 plus 3. 3 minus 2 is 1. So y is equal to 1. So then I bring it down here. Does that make sense?
Yes.
You always plug it back into one of the two original equations. Okay?
Gary, so you were talking
Yeah.
about yesterday,
Yep.
or 2 days ago,
Yep.
how sometimes you're solving it for like bubble gum or bubble gum and toothpicks.
Right,
How
in
would you
word
do that?
problems, you're going to
What
see.
type of word problem would you get where you had to do this?
I'd have to think about it. Well, I mean, anything. Like for, I could say 2 packs of bubble gum and 3 oranges cost $2.75. 5 packs of bubble gum and 1 pack of oranges cost $4.22. And then I would actually be able to create 2 equations from that. And you'll see, I'm going to be giving you one of those. Yeah, you'll be getting those in a little bit. And then you can figure out
The two equations,
cost.
then you figure it out.
Exactly,
Bubble gum versus
exactly,
orange.
exactly.
And then you would leave it
So
as
you
that.
think of basically the x would be your bubble gum, right? And the cost of your bubble gum, I believe. And your y would be your cost of your oranges, right? Something like that. You'll see when I actually give you some of those word problems. But good question though. So does that make sense? Fist of 5. It's pretty straightforward, right? Now where it's not straightforward is a problem like I'm about to put up here. I think everybody understood that one pretty easily. But what if I gave you this? 2x plus y is equal to -4, and x plus y is equal to -7. All right, so it's really quite easy. All I have to do is find the equation that says y equals or x equals. So you immediately,
What?
it doesn't say y equals or x equals.
Oh
Oh my gosh,
Gary, what have you done?
what am I gonna do?
You could do the like the minus x.
Oh,
minus
oh, wait.
whatever.
Oh, so say that again, Bella. So I could actually manipulate one of these equations. It doesn't matter which one, except that it might be easier to use the easiest one, right? So which one, Bella, would you choose? The bottom one. So let's manipulate it. How would I do it?
You minus x on each side, and then that would be.
All right. So I'm going to subtract x from this side, subtract x from this side, right? Do you guys agree with me? Because I want to move it over, and the only way to move it over is to add it or subtract it.
Couldn't you just like add y to -7 and
You could subtract y. Then you have -7 minus y. The trouble with that is then you have all these negatives, and it's easier for people to make mistakes when you have a lot of negatives. So I would rather just do what Bella said in this case. Y is equal to, and this, remember I put the x first, right? Minus x minus 7. Oh, we still have negatives. Okay, still have negatives, but that's okay. We'll deal with it. So now we have this equation now has become this equation. You agree with me?
But
Yeah.
if you subtract two negatives, oh wait, never
That's,
mind.
yeah, that's if you
no,
divide
I
and
was-
multiply.
yeah.
Yeah. So, okay, so I have to circle, I've got my y equals, here's my other equation, and here's my y equals, right? This is the same as this equation. It's just that I've manipulated a little bit. So, I'm gonna circle, excuse me, good grief. Okay, I'm gonna circle what y equals. And then I'm gonna rewrite my first equation, 2x plus, now this is what I have, y is -x minus 7. Actually, maybe I don't need the plus. I could just say negative x minus 7. Do you see why I don't need the plus sign there?
Yeah.
Does that make sense? Because if I'm adding a negative, it's just I'm subtracting. It's
And
the
then
same thing,
it's just
right?
x.
4 plus a negative 2 is 4 minus 2. You
But
see
then
that?
you get just x minus 7.
Okay.
Equals negative 4.
Well, wait a minute. So equals negative 4. So then I've got 2x's minus 1x is just x. Minus 7 is equal to negative 4. Now I'm going to add 7, right? Add 7 to both sides. X is equal to 3. Right? Everybody agree?
Kind of, yeah.
So just remember what we did. We looked for x equals or y equals, and there wasn't one. And so we said, okay, we're going to manipulate one of them. We turned this one into y equals negative x minus 7. I circled what y equals. That goes into this y here. So I have 2x, and instead of y, I put negative x minus 7 equals negative 4. I solve it, and I get x equals 3.
Y is negative 10.
Wait, if you have x minus x equals 3, so would you have negative 3 minus 7 for when you put it back in to find your y?
So yeah, if you wanted to use this equation, exactly. So you could plug this in now to this. So y is equal to negative x, negative 3 minus 7, which is what?
Negative 10.
Negative 10, everybody agree?
Yeah.
So y is equal to negative 10.
You
So my answer could be either that, or I could say 3 common negative 10, right?
Yeah.
Right? So that would be, either one of those would be correct answers. That make sense? Fist of 5, you guys get it?
We do a couple more?
You want to do, yeah, let's do another one. Can I erase this?
Yeah. We do like 2 more negative.
Yeah, let's just do a couple more and see if we have time. Just to practice
How much more time do we have?
in class.
Like
So we have
6
about
minutes, 7 minutes?
7 or 8 minutes, something like that. So we'll see. And then let me just, okay. Okay, here we go. Let's try this one. 4y minus 5x equals 9. And then I have x minus 4y equals 11. Okay, so again, I just look where it says x equals or y equals and I circle it. It doesn't. Bummer. So what do I do?
Use the bottom.
So Isa.
You use the bottom one. You add 4y.
Okay. So in this case, we're gonna solve for x. We're gonna have x equals something, right? So okay, we're gonna add 4y, and so that's gonna give me x equals, because these cross out, right? 4y, and that's a positive 11, so plus 11, right? So 4y plus 11.
Wait, wouldn't you do 11 plus 4y?
Oh, wait, I did that wrong.
Well, you could do either way. Either way is fine. Doesn't matter. You could have done 11 plus 4y. I just have this habit of always putting my variable first and then my number at the end, because in algebra, many equations work that way. You know what I mean? You have the variables first and you have the number without the variable at the far right. So I just tend to do that.
You can move it around.
But you can move it around. It makes no difference. Yeah.
Okay, so
Right? So we know that. So we just manipulated this one, right? So this is our other equation that we have to substitute in for. I'm going to circle what x equals, and I'm going to remember that I'm going to substitute that into this x right here. You guys with me? Make sense? So here we go. I'm going to write 4y minus, I've got to write the 5, but now I have a mess here. I call this a blob, right? It's actually a binomial, right? But I call it a blob. But it's a binomial, right?
So would you put it in parentheses?
Yes!
Parentheses
You
for
got to
y.
put the parentheses because it's 5 times the blob, right?
wait, can't you
So
cross out the 4y with the other 4y though?
No, because they're not.
Well, not yet, not yet, not yet. You want to first, want to substitute it in, you know, so that it's pure, so that you can see
But
what you're
about the
working
plus
with.
11?
So I've got 4y.
It's on
Just hang on, guys.
4y plus 11.
Give me a second. Okay, equals 9. You guys agree with me? Did I do this right?
No.
4y minus 5 parenthesis, and then the x. 4y plus 11, parenthesis, equals 9. Those parentheses are really important because it's not just 5 times the 4y and then plus 11. It's 5 times everything, 4y and 11, right? You got to multiply the 5 times both of them, the negative 5 in this case. So let's keep going. We got 4y, and now I've got to use my distributive property. Do not forget that there is a negative sign right there. So that is a negative 5 times 4y, right? So that's negative 20y, am I right? And then it's negative 5 times 11, so that's negative 55 equals 9. Looks hard, doesn't it, with all these big numbers?
And then you add the
So what is 4y minus 20y?
Negative 16y.
Okay, negative minus 55 equals 9. Now what would I do?
Add 55 to both sides.
Add 55 to both sides, good.
74.
So I've got negative 16y is equal to
74? No, wait, no.
64, right? Am I right?
Yeah.
Oh, 16 goes into 64 evenly.
Yeah.
I think 4 times, right?
4 times.
So if I divide both sides by negative 16, right?
Wait, is it positive or negative?
So yeah, the key is you want it to say y, right? You don't want to say negative 16y.
Oh, yes,
You want to
you
say
got it.
y. And so whatever is in front of y, you divide it by, right? And if it's positive, you divide by the positive number. If it's negative, you divide by a negative number. Anything that's in front of the y, you divide the whole thing by. You know? And so now the negatives cross out, the 16s cross out. All I have here is y equals. Now I have positive divided by negative. Is it going to be positive or negative? Negative.
Negative 4.
Okay, and then it's negative 4. Great. So are we done?
No.
No, why?
We
No,
need to
no,
find out
let's
what
find
x
out the
is.
x.
We have to figure out what x is. Oh dear, what a mess. Which one are we going to use?
X
Well,
minus 4.
As long as we're sure we did this right, we can use this one, right? As long as we're sure that we did the right thing. We didn't say subtract, we didn't subtract 4y from both sides or something like that. As long as we're sure, then we can substitute it into this one. So we'll try it, because x is equal to 4 times negative 4 plus 11. So that is, x is equal to negative 16 plus 11.
Negative 5.
So x is equal to negative 5. So I could say over here, x is equal to negative 5.
Can we do another one like that?
Or I can do, yes, or I can do negative 5, always the x first, comma negative 4. Okay? Right? And again, the reason why that's written as a coordinate for our shadows is that basically when you have two equations, you have two straight lines. And you're looking for that place where they cross, which is a place on a graph, right? So you guys know how to graph, right? You go x over to the, whatever.
Is it possible if you get those coordinates,
Possible what?
is it possible if you get those coordinates and maybe something else to figure out the two lines? Like, if you get something else along with those two coordinates, because otherwise.
And you figure out the two lines? Well, there would be an infinite number of lines that would go through that point.
Right, but if they gave you something else, like if they gave you what?
Yeah, probably. I'd have to think about it, but yeah, I'm sure you could. If I said, I mean, you will be getting things sometimes, but not necessarily with systems of equations, but sort of.
Like, there's an intercept
Yeah.
here.
But let me just do, you guys want me to do one more
Yes.
really fast, just so that
We're
we're,
gonna have
well, we have 3 minutes,
3 minutes.
I think.
A lot of time.
All right, so I think we can do it in 3 minutes. Let's just try.
Speed run.
Okay, speed run.
speed running tactics.
Okay, here we go.
Go Gary.
Sure. Well, I don't know.
Gary, hurry up!
I want to try to do one that's a little harder. Hang on. Those aren't very hard. Okay, how about this one? How about this? 4x equals y minus 1, and 6x minus 2y is equal to negative 3.
Well, you
All right.
can use the first one.
So
use
yeah,
the
let's
first one,
use
you
the
can
first
add
one.
one.
What if we added 1 to both sides here, right? If we add 1, that would give me, I'm gonna write my y first, okay? If this is equal to y, then y is equal to this. So I'm gonna write my y first. This crosses out, equals 4x plus 1. You agree with me? You see what I did?
Yes.
Even though the y would normally be on the right, I like it on the left, so I'm putting it on the left. Okay, and then I have this one. So I know this is my y. I'm going to substitute that in for my y, right there. So here we go. 6x minus 2 parentheses 4x plus 1 equals negative 3. All right, so I'm going to use my distributive property. I'm not going to forget that I've got a negative 2 here. So I have 6x minus 8x minus 2, right? See that? Negative 2 times 1 is negative 2 equals negative 3. So 6x minus 8x, negative 2x, right? Minus 2 is equal to minus 3. I'm going to add my 2.
Wait, 22. Oh
Right.
my god.
Wait,
that's
never mind.
lovely.
Okay, so then I've got negative 2x is equal to, these cross out, right? Is equal to negative 1, am I right? Okay, now I don't like the negatives, but actually I'm going to just divide by negative 2 because I want to say x. Divide by negative 2. Now, when I do that, I've got negative divided by negative, they become positive, and 1/2. So x is equal to 1/2.
So you
That make sense?
Yes.
All right, so x is 1/2. Now I've got a, doggone it, we have a fraction. Oh, right? So now I've got to find out what y is equal
2
to.
plus 1.
So y is equal to, what is half of 4?
2.
2, right? So if it's just 1/2, I could write 4 times 1/2, or I could just say, well, what is half of 4?
So y is
So
3.
it's
It's 2. So it's 2
So y is 3.
plus 1, so y is equal to 3. So, and then x is equal to 1/2. Okay, wait, what? Did somebody lose somebody?
No.
So my final answer would be 1/2, comma, 3. Is it okay to have a fraction in these things?
Yeah.
Yeah.
Just
Yeah.
please.
Okay,
Yeah.
so you have 2 equals y minus 1,
Where?
where,
Yeah, y equals 2 plus 1. Because when you multiply
So y is equal
4,
to,
multiply 4 by 1/2, which
oh, it's
halves
x,
it,
I put the
and
2
makes it
in
2.
the place
right, I should have just written this out and before I did it. But
of. Okay, so
whenever it's half, I just say, what's
4
half
times
of this?
1/2 is 2.
4 times 1/2 is the same as saying, what's half of 4? Which is 2. So that'd be 2 plus 1, which is 3. Makes sense?
Simple math.
Okay, so that's systems of equation by substitution. We're done now with substitution. I will give you the homework. Let me stop this thing.